You probably think of a database table as a place to store data. It isn't. It's a set of rules about what data is allowed to exist. The storage is a side effect. The rules are the point. Most developers spend years working with databases before they fully feel the difference between those two things. And the cost of not feeling it shows up as bad data that got in, production incidents that didn't have to happen, and bugs that are technically the database's fault, but are actually the developer's assumption. Here's what enforcing a shape actually means. Imagine a warehouse with hundreds of shelves. Each shelf has a label: name, date of birth, account balance, order status. You can put anything on any shelf. A date of birth shelf holds a name. An account balance shelf holds a sentence. The warehouse doesn't care. It stores whatever you hand it. That's a database without structural constraints. It holds whatever arrives. It never asks whether what arrived makes sense. Now imagine the same warehouse, but the shelf for date of birth physically cannot hold anything except a valid date. The shelf for account balance physically rejects text. The shelf for order status only accepts values from an approved list. The warehouse itself is enforcing the rules. Nothing gets in that doesn't belong. That's a database with structural constraints. The shape of the data is enforced by the structure of the table, not by the code that writes to it, not by the developer who designed it, not by the team that maintains it, by the table itself. This distinction matters more than it sounds. Application code can be bypassed. Validation in your API can be circumvented by a direct database connection. A developer writing a data migration script might skip the application layer entirely. A third-party integration might write directly to the database without going through any of your validation logic. Every path that writes to your database that doesn't go through your application code is a path that bypasses every rule you wrote in your application code. The only rules that cannot be bypassed are the rules enforced by the database itself. Structural constraints are those rules. They are the last line of defense between your database and data that should never have existed. Let me show you what happens when that last line is missing. In 2017, a healthcare company migrated patient records from a legacy system to a new platform. The migration script was written quickly, under pressure, by a developer who had full database access. The new table had a column for patient date of birth. The column was defined as a varchar, a text field. The developer stored dates as text strings. The database accepted everything. The migration completed successfully. 3 weeks later, a query processing date of birth values for age-related medication dosing returned results that made no sense. Some patients appeared to be 134 years old. Some appeared to be born in the future. One record had a date of birth stored as NA, because the legacy system had used that string for unknown values, and the migration script had transferred it without conversion. The database had enforced nothing. The text column held whatever text it was given. NA is valid text. 185 is valid text. Tomorrow is valid text. None of these are valid dates. The column couldn't tell the difference. The dosing algorithm couldn't handle the difference. The patients were real. A date column would have rejected every one of those values on arrival. The migration would have failed loudly, forcing the developer to handle the bad values explicitly before they reached the table. A varchar accepted them silently, stored them permanently, and let the problem propagate downstream until a dosing algorithm revealed it 3 weeks later. Structural constraints come in 3 forms that together define the shape a table enforces. The first is type constraints. Every column has a type: integer, date, Boolean, decimal, text. The type defines what values are physically accepted. A date column accepts dates. It rejects everything else. It rejects decimals, text, and everything else. Type constraints are the most basic form of shape enforcement and the most commonly weakened by developers who reach for varchar when uncertain, not realizing they are disabling the most fundamental check the database can perform. The second is not null constraints. A not null column refuses to accept a missing value. Every row must provide a value for that column, every time. A missing value doesn't behave like any other value. It behaves like unknown, and unknown propagates through calculations and queries in ways that are silent and dangerous. Not null stops unknown from entering in the first place. The third is check constraints. A check constraint defines a rule that every value in a column must satisfy. Account balance must be 0 or greater. Order status must be one of pending, confirmed, shipped, delivered. Age must be between 0 and 150. Check constraints enforce the business rules that type and not null cannot capture. They close the gap between technically a valid integer and actually a valid age. Together, these three form what you can think of as the table's shape, not the shape of the data that happens to be stored in it, the shape that every piece of data must conform to before it is allowed to exist in the table. That shape is not optional. It is not documentation. It is not a reminder to developers to write good validation. It is a physical restriction enforced by the database engine itself, applied to every insert, every update, every migration script, every third-party integration, every direct database connection, without exception. The reason so many databases in production have weak shapes is not that developers don't know constraints exist. It's that constraints feel like friction when you're building fast. Vasha is flexible. Date is rigid. Under deadline pressure, flexible wins. Allowing null means you don't have to figure out a default. Not null means you do. Skipping a check constraint means you can insert test data without worrying about valid ranges. Each of these shortcuts is locally rational. Each of them removes a rule that the database was going to enforce for free, forever. And the cost of removing them doesn't arrive during development. It arrives in production, months or years later, when data that should never have existed causes a problem that traces back to a column that accepted whatever it was given. The table's shape is the first thing you define. It is often the first thing weakened under pressure. And it is the one thing that cannot be fixed, retrospectively, without finding and correcting every bad value that entered through the gap you left open. Define the shape before you write the first query. Make it as strict as the data it holds. Use date for dates. Use not null unless absence is genuinely meaningful. Write the check constraint that encodes the business rule, so the database enforces it instead of hoping every developer remembers to. The shape of a table is a promise about what data is allowed to exist. Make that promise as specific as possible. The more specific the promise, the harder it is for bad data to find a way in, and the less time you spend explaining to a dosing algorithm why a patient's date of birth says not available.